Hello and welcome to the Oshkosh Additive Manufacturing Senior Design Project. I'm Spencer Butke.
I'm Hannah Wright.
I'm Salo. I'm Zach Barrette.
And our sponsor contact is Colin Rittner from Oshkosh.
Beginning this project, we faced a lot of roadblocks throughout the year. First is we had to research multiple types of additive manufacturing methods to find out which would be the best fit for this project. On the right is a overview or a picture of our industry report, which covers all of our research, all the defects that could possibly come from every method and so forth. Also material research as well. After deciding on a specific method, we continued to testing. We printed fatigue and tensile test samples and tested them on the machine to compare these to FDA results. We continue on to CAD modeling to model and optimize the part as much as possible, and then test them in FDA with different kinds of load cases. On the right is a post-test tensile test sample that we thought would be useful in this project or be something to see.
Okay, on this slide is going to be the solutions. So we 3D printed, as Hannah said, some test samples, 3 solids, 3 30% and 3 60% out of 17.4 stainless steel. On the left is the printed test samples while they're in the machine right after printing. In the middle is the lattice structure that we chose for the 30% and 60%. And on the right is a model of the knuckle, which is the part that we were assigned to by Oshkosh. And the red is the areas of the part that are going to have the lattice structure. And the purple is going to be the areas that are solid. These were chosen to be solid because they're a critical area of the part and have high tolerances. So having them solid reinforces that they won't change, and that during the machining process that there won't be any defects.
So for the FEA, what was all involved was we did a partial solid part. So around the critical bearing surfaces, it'll be a solid part, and then around the less important material will be more of a lattice infill of 30% to help cut down on the weight, since it's a stainless steel. It currently is around 32, 36 pounds, roughly, depending upon powders trapped in there or just variations in the density of the lattice itself. But which is, so it'll be fairly light for a steel knuckle part, and it does it is very strong and rigid for the low cases that Oshkosh provided us for when we did our FEA analysis. It should be able to stand up to any of the forces that it is subjected to. And on the far right in the picture, that is the powder bed, which machine that we are currently using. MTU currently has one in house, and that's what we printed our tensile bars. And we hope that the next team will print the actual knuckle.
And then for our last slide here, moving forward, we're going to present our proof of concept. So the final part that's made or that's printed, we're going to show them that. And that's going to have the lattice structure inside. It's going to be cut in quarters, so we'll be able to see the 30% lattice structure that we're using. And then we're going to basically take everything that we've done this semester, organize the findings for next year's team, so that's all in one spot for them, and they can review that and hit the ground running next year right away. And then we also created a tentative project schedule for next year for them as well. So that'll keep them on track and let them know what's expected of them, so they have a successful year on their project.